Emily can finish a 500-piece puzzle in about 8 hours. When Emily and Sposy work together, they can finish the puzzle in about 4.5 hours. About how long does it take Sposy to finish the puzzle if she works by herself? Right, this was constantly asked on those midterm exams when I taught at IU. So they always ask these questions. And everybody always answered 3.5 hours. So why is it not 3.5 hours? Why does that not make sense? Yeah, Anthony.
Because that's on a rate when they're together. Not when they're
Yeah, like when they're together, it took them 4.5 hours. So how can she do it working by herself in 3.5 hours?
I mean, technically they could break the pieces up 250 each.
Yeah, but it doesn't make any sense that it would take her less time than it took them working together, right? So there's something going on there. There's something wrong with that. So the key to working these problems is to think about how long or what portion of the job they can get done in 1 hour, so 1 unit of time. So in 1 hour, Emily can do what fraction of the whole job? I heard someone say it. What did you say?
1/8.
1/8, right? So Emily can do 1/8 of the job. So making the puzzle. Does it make sense? Because it takes her 8 total hours. So in 1 hour, she can do 1/8 of the job. She can do 1/8 of it. All right, in 1 hour, together, they can do, so this number is a little weird. If it took them 4.5 hours together, they can do 1 out of 4.5 of the job. It makes more sense when it's nice whole numbers. Like if it was 4, they'd do 1/4 of the job. So I heard someone say X. Mitch is saying X.
No, I just said thanks.
Oh, thanks for giving you weird numbers. Okay, so we need to figure out how long it takes Sposy to work by herself. So we're going to say let X equal amount of time for just Sposy or Sposy alone. Okay, so in 1 hour, what portion of the job does she do?
X plus 4.5.
No. So if it took her 10 hours, she would do 1/10 of the job, right? So in 1 hour, she does 1 over X of the job. See, it's always 1 over, 1 over, 1 over.
What is it?
So I was just talking about if it said like 70 minutes, in 1 minute they do 1/70th of the job. Makes sense. Okay, so individually, so Emily does 1/8 of the job, and Sposy does 1 over X of the job. So that's together, right? Individually 1/8 of the job plus individually 1 over X of the job. So together they do 1 over 4.5 of the job. Does that make sense? So it's Emily plus Sposy equals together. All right, so this is an equation that we just learned how to solve. Daniel looks confused. What are you confused about? What am I going to multiply through by? Yeah, just use all 3 of them. So make it 8 times X times 4.5. Oops, my pen's not working. So 8 times X times 4.5. This does that. Okay, so on the first one, what's going to cancel? Do you want me to write out that step where you see it times each one? Some people like to see this, but so do you guys see on the first one, just the 8's cancel? So you're left with 4.5x. On the next one, just the x's cancel. So I'm left with 8 times 4.5. Is that 36? Is that right?
Yeah.
On the next one, the 4.5s cancel, so I have 8x. Okay, subtract it out. 4.5, if I subtract the other side, it's 3.5x equals 36. 36 divided by 3.5. Will someone find that? So let's say 10.29 hours. Okay, that's how long it would take working on them. These usually aren't very nice numbers, by the way. Okay, so makes sense. You're always doing what fraction can they do in 1 hour? What fraction can they do in 1 hour? Okay, so here's the other type of question. Okay, it says a jet travels 3,950 miles from Chicago to London and 3,950 miles on the return trip. The total flying time is 16.5 hours. So have you guys ever done that where you've flown to like California and it took you a really long time on the way there, but then it took you a little bit less on the way back? Yeah. So when you're flying against the wind, you're going slower, but when you're flying with the wind, it's pushing you along faster. So that's what's going on. It's not taking you exactly 8.25 hours there and 8.25 hours back. It's taking you 16.5 hours total. All right, so as the return trip takes longer due to winds that generally blow from west to east, if the jet's average speed with no wind is 485 miles per hour, what is the average speed during the round trip flight? Round to the nearest miles per hour. Okay, I set up the table for you. Okay, I would probably do this if I asked this question on the test for you. So here's what's going on. The first thing you set up in your table is the distance. Both distances are 3950, so those numbers are already there. So Luke, do you see the average speed is 485? So that's your average speed with no wind, so it's 485. So going against the wind is going to make you go slower. So you subtract out the wind speed. So if the wind was blowing like, I don't know, 80 miles per hour, you would be going 405 miles per hour. All right, same thing with wind. Now it's going to be plus the wind speed. So it would push you along faster. Okay, so those are the only two things you really need to know to fill out the table. Then you can figure that out, or then you can figure out what goes in the time. So how are distance, speed, and time related? What equation, Anthony?
Distance equals rate over time.
Close. Distance equals rate times time, right. So rate times time. So that means if I'm solving for time, time is just divide your rate over. Distance over the rate. That's how you got this whole column here. Did you see you just took the distance, 3950, divided by 45 minus W? It's there. 3950 divided by 45 plus W, it's there. Okay. These two things add to 16.5. That was your total flying time. So that's going to be your equation. So I'm going to have 3950 over 485 minus W plus 3950 over 485 plus W equals the total amount of time, 16.5. So what would you need for your LCD?
This is like the
48.
Yeah, you need both things. You see what Melanie's saying? You need 485 minus W times 485 plus W. You need both things. All right, so you would multiply this whole thing by both things. Okay, so I didn't make these numbers very nice. So we're not going to waste time to do this one. But that's your setup. Oh, thank you, Mitch. It's minus. Thank you. So I didn't make them very nice. So since they're not very nice, if you can do this, I'll give you 1 point. So by tomorrow, if you can do it. So give me the correct wind speed, and I'll give you a point. I'll do that very often. All right, next up, so rational inequalities. So a rational inequality is an inequality that contains one or more rational expressions. So it says we solve rational inequalities using critical points. Do you guys remember critical points? That's when we had like 2 and 5, and we tested things on the left, in the middle, on the right. We'd see when it was positive, negative, positive, so on, you know. It's been a while. Okay, so we're going to use critical points again. It says, first you find the value of x that makes the two sides equal. That's a critical point. It says also make sure you check to see what makes the denominator equal to 0 as well. That's also a critical point. Okay, so here's what we got. We're going to find when we have things that are equal and when our denominator is equal to 0. So what I mean by equal is instead of having this inequality sign, less than or equal to, I just have equal. So I have x over x minus 6 equals 3. And I solve that out. Now you can think of the LCD, multiply 3 by the LCD. But this is just, I mean, think of if I had x over 2 equals 3, how do you solve that equation? You just take that 2 and you multiply it over, right? That's what we're doing here. So just multiply your x minus 6 over. That's the same thing as multiplying 3 by the LCD. We're just multiplying it over. So I get x equals 3x minus 18. Subtract your 3x, you get negative 2x equals negative 18. So x is 9. That's the first critical point. Now when I set my denominator equal to 0, I get x minus 6 equals 0, so x equals 6. That's the second critical point. Those are the numbers that go on your number line. Okay, now we're just checking. So we're checking each interval. I want to check a number that's less than 6. A number that's less than 6, I think maybe 0. So we're going to check some points. So when I plug in 0, I get 0 over 0 minus 6. I want to see if that's less than or equal to 3. So that inequality is 0 is less than or equal to 3. True or false? True. So you can do like a check mark or you can write true. So it's going to be over there. Okay, next one. Let's try 7. I'm trying 7 because 7's in between 6 and 9. So I have 7 over 7 minus 6. Is that less than or equal to 3? So I get 7 is less than or equal to 3. That's false. That's not true. Okay, and the last one, let's try 10. When I check 10, I have 10 over 10 minus 6 is less than or equal to 3. Okay, that gives me 10 over 4. That's 2.5. It's true. Okay, we want to shade what makes it true. So I'm shading on the left and I'm shading on the right. So all those points will make your inequality true. What about the endpoints?
We put a dot on 6.
Good question. Do we have to do a filled in dot or open circle? Filled in on 6? So go ahead and check 6 in your original. What happens? 6 over 0, right? So when you check 6, you get 6 over 0 is less than or equal to 3. So that's going to be open. Okay, but what about 9? When you check 9, what happens? Yeah, you get 3 is less than or equal to 3. Is 3 less than or equal to 3? Yeah, so that has to be included in those points, so we fill that one in. Or not 3 gives, 9 gives. So when I check 9, it gives 3 is less than or equal to 3. So fill it in. Does that make sense? Do you see why one's filled and one's not? All right, and then I'll probably ask you interval notation on your test. So it'd be negative infinity to 6, parenthesis, union, bracket, 9 to infinity. So remember, it's brackets when you fill them in, parentheses otherwise. And infinities never have brackets. Okay, so if you check those numbers, if you check 6 in your original, do you see how you'd get 6 over 0? Okay, that's undefined. So that's not going to be less than or equal to 3. We don't know what that is. So that's open. But when you check 9, see how if you check 9, you get 9 over 3. So that's 3 is less than or equal to 3. Is 3 less than? It's exactly 3, so it needs to be filled in.